right, so I just told you that being able to combine series into one big series is important to you. And I promise it's pretty much all we'll do in this section. So we're going to do an example where we practice that skill. I did write down the problem for this one. It's section 5.1, problem 1. And what we want to do is we want to represent this infinite series sum from n equals 2 to infinity n times n minus 1 cn x to the n minus 2 plus this infinite series from n equals 0 to infinity. I'm sorry, that's actually, I want to subtract right there. No. Okay. N minus 2 minus that second one. Sum from n equals 0 to infinity cn x to the n plus 1. We want to take it and represent it in one series. So instead of having these two different sum signs, we want to have one sum sign that describes both of these things at the same time. So I'm going to call our series just capital S. Goes from n equals 2 to infinity, n times n minus 1, cn x to the n minus 2, minus sum from n equals 0 to infinity, cn x to the n plus 1. And I told you that the two things that have to happen is we have to have the same lower bounds and the same powers of x. So let's do the lower bounds first. We want to move these so they have the same lower bounds. Let's go ahead and have them like meet somewhere in the middle. So this one starts at 2, this one starts at 0. So let's say we want both of them to start at 1. So I want to make that one from n equals 1 to infinity, and I want to make that one from n equals 1 to infinity. So if I had cn right here before, when I started from n equals 2, my first term would have looked like c2. If I'm going to plug in n equals 1, my first term would have to be cn plus 1 to still get c2 for my first term. Similarly, if I started from n equals 2, I would have had x to the 2 minus 2 is 0 for my first term. If I'm going to plug in n equals 1 to start, my x is going to have to be to the power n minus 1. Now when I plug in x to the n equals 1 minus 1, I'm going to get 0. So they'll stay the same. And then this n times n minus 1, let's just think about the two parts separately. This would have been 2 times 2 minus 1 is 1. So if I'm starting from n equals 1, then if I plug in n, that's going to give me that 1. And if I plug in n plus 1, that's going to give me 2. 1 plus 1 is 2. So I'm going to underline those in blue and just say that that's checking first terms match. For anyone who's reading through the notes afterwards. Basically what I did was I said my series has to start from a new value. It starts at n equals 1 now. So I'm going to rename everything that's inside the series so that when I plug in my first n value, I still get the same first term as I had before. Okay, so then let's do the same thing with this second series right here. So before I started at n equals 0, so my first term would have been c0, x to the 0 plus 1 is 1. I will underline that in blue again. And so if I'm going to start from n equals 1, and I want to get c0 for my first term, I need to use cn minus 1. Then that'll give me c1 minus 1 is 0. And then if I want my first term to be x to the 1, but the thing I plug in to start is 1, then I'm okay with just a regular x to the n. All right. So I've done this first thing. I went ahead and I made it so that the lower bounds match. Now I need to make sure that the powers of x match. So let's go ahead and try that. I see that this is x to the n minus 1. That's x to the n. So somehow I haven't done enough. These two series can't combine yet because their powers x are different. I need to think about how I can fix that. So I know that going n equals 2 to n equals 1 took x to the n minus 2 to x to the n minus 1. So now I'm thinking, okay, if I move my lower bound again, I'll probably end up with x raised to the power n, which is what I want to see. So I say, okay, I guess I'm going to try being from n equals 0 to infinity. Now, my x to the n works. That gives me x to the 0. But I have to change all of this stuff now. Again, before I wanted to start at 2. So C0 plus 2 would give me C2. So I better do n plus 2 right there. And then to get 1, when I plug in n equals 0, I better have n plus 1. And to get 2, when I plug in n equals 0, I better have n plus 2. So that's, again, I changed the indices, so I made sure that the first term lined up. I didn't change the second thing at all. But now my lower bounds don't match again. And that's a problem for me. So I still want the lower bounds to match, and I just undid that with the power that I introduced. So we have to use kind of the definition of the series to help ourselves get out of this problem. So real quick, let's just kind of think through what, Okay, sorry, my pen isn't working right now. I'm trying to circle the first series. Just imagine a circle is appearing while I figure this out. Okay, there it goes. So I want to just think about what that series is going to look like. So when I plug in 0, I'm going to get that 2 times 1 times C2 x to the 0. And when I plug in n equals 1, I'm going to get 3 times 2 times Cn plus 2 x to the 1. Oops. So on and so forth. So the series still represents an infinite sum of things. I can always go ahead and just pull the series apart. I can say, I'll think about this part and this part separately. So I've got 2c2 x to the 0. And then I've got plus everything else. I still use this n plus 2 times n plus 1, cn plus 2 x to the n. But I threw away my first term at n equals 0, so I start from n equals 1. So what I've done here, oh no, that eraser is too big. Okay, I just want to underline it so it's kind of clear what's happening. Cool. So I pulled apart these two different things. Let's do double underlines right there. And I just pulled them apart to get rid of the bad lower bound. And then from here, I have my two conditions met. The lower bounds are the same, the powers of x are the same. I can circle that here. Lower bounds both start from n equals 1. That's great. Powers x both start from x to the n. That's great. So I can combine these series. So my 2c2 is stuck there. That is a bad sum sign. So my sum is from n equals 1 to infinity, uses x to the power n. Actually, let's give ourselves even more room. And then I can just fill in what belonged to the two separate sums from here. So I had n plus 2 times n plus 1 times cn plus 2 minus cn minus 1. And that's just arithmetic. That part goes there, that part goes there, and that sum, or that difference goes there. And that's the solution.